Hello, everyone. Welcome to week 9 of Building Server Systems. Um, this week, we are going to expand our knowledge of HVAC. So if you recall, in week 8, we went over the basics of HVAC and refrigeration cycle and sort of how HVAC systems work, looking at forced air systems and heat pumps and so forth. So this week, we're going to investigate how commercial buildings are often heated and cooled. Now, this is not a comprehensive overview. There are additional systems, but these are some of the most common systems you'll see in modern commercial buildings. And so, as you'll see, the basic thermodynamics and the basic premise of heating and cooling are the same for commercial buildings as residential, but they're kind of, they're on a bigger scale, and usually they're a little more complex. Now, it depends on the size of the building, but you consider a building like Delaware Tech. So I'm sitting here at the Stanton campus. We have somewhere around 200,000 square feet of conditioned space. There are a whole bunch of different systems that are sometimes well integrated, sometimes not, but we have basically every type of system you can imagine here, and it gets pretty complicated. Making a commercial building of this size and with this many different uses can get pretty complex. And so, again, I just want to kind of give you a sense of some of the most common ways that commercial buildings can sort of deal with the size and the complexity and so forth. So by the time you're done with this lesson, you should have a pretty good understanding of again, some of the most common ways that commercial buildings are heated and cooled, and to some extent deal with humidity. And so you can see the lesson starts here with a cooling tower, which is a really, really common way to sort of what you end up doing is providing some cooling. So it uses evaporative cooling, which you'll see here. It's a pretty, fundamentally pretty simple. You're basically just running water, warm water, through a big space with a fan that blows air through it, and it just evaporates some of that water, which, as you know, extracts some of the heat because evaporation requires heat. You have some of that latent heat that goes up into the vapor. And so this is a really common way, pretty low energy way to provide cooling for a building. We have a whole bunch of them here at the Stanton campus, for example. You'll see them on top of commercial buildings all over the place if you know what you're looking for. And there's there's a couple of different types of cooling towers. Just wanted to kind of show you that there's not just one single technology, to give you a sense of that there are different ways that this can operate. And then we start digging into how heating and cooling, like inside the building, is distributed. And there's a couple of videos here that help explain how a large commercial building integrates a couple of different systems, like a cooling tower and a chiller and an air handling unit and so forth. And so you go over some of the basics of chillers and cooling towers, air handling units. There's a video on rooftop units, which is incredibly common. If you know what you're looking for, there are RTUs absolutely everywhere. Again, I'm making this video in Delaware, which is the land of plazas. I mean, there's just plazas all over the place. Every store seems to be in a plaza, and if you look on top of the store in the plaza, there are usually these single-story buildings, and if you look on top, you'll see these boxy things on top. Those are almost always rooftop units. Sometimes they're actually small cooling towers. But anyway, this is a really, really common way to heat and cool buildings. And a rooftop unit heats and cools, and there's a couple of different configurations. So we'll go over the basics of a rooftop unit, and then this video is a really good one that shows you how all of these are integrated together. It's pretty common to have a chiller, or excuse me, a cooling tower that sort of pre-cools some water, and then that water will go into a chiller, which then really chills the water, and then you send chilled water out into the building into what are called air handlers or air handling units. And then basically what you're doing is you're just running cold water out to different units throughout the building through a series of pumps. And you can pump cold water out there, and you basically just you put that cold water through a coil, and you just blow a fan across that cold metal, and that provides cooling to the building. That's a very common way to cool buildings, using a chiller and a chilled water loop. And this whole system is all integrated together in a series of loops. And so it's hopefully you have a good sense of how that works and how all those systems are integrated. And then this video goes over ERVs, or energy recovery ventilators, which are really great way to reduce energy use. And I'll just let the video sort of speak for itself. And then the summary video, in the summary video, I go over that key concept. All right, so this gives you a really good sense of a lot of the, again, the most common commercial HVAC systems that you'll see. And hopefully after you watch these videos and you kind of go through all the content, you'll start noticing these systems all over the place, because they're absolutely everywhere. If you're just sort of walking around or driving around or even walking around any of the Delaware Tech campuses, these are all over the place. Okay. And then there's just a short video here and a short explanation about different efficiency metrics for heating and cooling systems. So we'll go over SEER, HSPF, which are those are for heat pumps primarily, and then AFUE, or annual fuel utilization efficiency, which is for furnaces. Okay, so we'll go over the basic principles there. Make sure you read those couple of pages in your book as well, and then there's a summary video as well. And there's a couple of quizzes based on that, based on this content. So you see there's actually a regular quiz where you get 2 tries. And there, you notice here there's a calculations quiz. So this calculations quiz is all based on this HVAC efficiency. And you'll see that you can take this quiz as many times as you want, and only your highest score will count up until the due date. All right, so you actually take the quiz and it'll show you the answer, and then you can retake the quiz until you get a score that you're satisfied with. Okay, so that's the content this week, and then of course David has a good lab for you this week, but I'll let him introduce that. As always, if you have any questions, let me know, and I hope you enjoy the content.